Completed?
Yes, sir.
Sir, when to change the script from everything to the characters' names? And
Sir, use the script I have shared in WhatsApp, separate script. As a text
sir,
I have shared, use that.
yes, sir. But yesterday we have day before yesterday we have used everything command. And
Yeah.
now it has been changed. I'm just asking.
Sir, it is like any government policy in small with font 6, it is written terms and condition apply. So this R is like that only. You need to change according to the date, your input file requirement.
Okay.
So why we deleted that, or why we not considered those two, that also I will tell you now only. But just let others complete this thing, then I will tell you why we excluded those two characters.
Okay.
Sir, please check your WhatsApp once.
Whether your input file name is data, Danish?
Sir, it's a trait. I have to change it, I think. Yeah.
Yeah, Soundarya madam.
Sir, what I just want to confirm in this graph there
Okay.
is three groups like FA1, FA2, FA3. So
Yeah.
we studied in the last class, they divided into two FA1 and FA2 based on the data. Like some are yield, some are yield.
So here same way here 3 factors are there.
Yes, and with this, the genotype data, only three genotypes are like a best performing.
Selected across
Selected.
environment. Yeah.
Okay.
Stable and high performing.
Stable and high. Okay, sir.
So actually this MGI-DI will select the genotypes on the basis of performance only, not stability.
Perform. Yes. Okay, sir.
Yeah. For stability and performance, we have the next models that the scripts I have shared now. So that models will consider stability as well as mean performance.
Okay, sir.
Yeah. So,
Excuse me, sir.
Pawan.
Sir, it is still in the last line. It is showing that object AKU not found, where you have put P1 is equal to plot AKU, comma type is equal to contribution. I copied the command which you sent just in that WhatsApp group.
Yeah.
But still it is not showing up. It's showing object AKU not found.
So any other member who encountered the same error? So what you did, you copied everything and you pasted at a time.
No, sir. Just first I have calculated it, and after that second thing I am going for it plotting.
Yeah. So do it first, set the model, then go for A line, then AKU, then plotting.
Okay, sir.
So whether you done that library maintain,
Yes, sir. Library run is completed.
whether you have changed that data file to traits.
Yes, sir. Yes, sir. My file name is AMI data. I have changed that. And sir, in the WhatsApp command, you have
And
just send the 6
AMI
traits.
data, which data you are using?
So file name.
Which data you are using? They like 3-4 files I shared to you. So which data you are using? That's what I am asking.
Which you sent today in the mail with the name of traits.
So change it and use today's WhatsApp file. That's what I told. Use this file, WhatsApp file.
Okay, sir.
Yeah. So we have excluded these two observations from this table. That is NPP and HSV. So what may be the reason? Anyone? From anyone? What may be the reason?
For them, Amy is not showing. Sir.
Yeah, anyone?
Sir, can you repeat the question?
Yes, sir.
So the thing is, I am asking, we first tried with all the 8 characters, right?
Yes, sir.
We first tried with all the 8 characters, but we encountered error. Everyone, including me. Then we excluded the 2 characters and we run the command with 6 characters. So we got successfully output file along with graph. So my question is, can anyone tell why we excluded those 2 characters? So simple reason is, as everyone knows that whatever the observations are there, so this MGDI, that is Metten package, it will divide those observations into different factors. So as here you can see plant height and OC. So those 2 characters, they are contributing to factor analysis. Right? Or suppose they have some variance. So here you can see the standard deviation, heritability, then these traits are there. So this NPP, HSV, they are not contributing anything to factor analysis with 0 variance. That's why we encountered the error. So
Sir, can you repeat?
Yeah, so whatever the characters we are studying, so those characters up to more or less extent, they are contributing to factor analysis, like this days to flowering, days to maturity are there in one factor, so they are contributing. Then this yield and PC, they are in one factor, pH and OC, they are in one factor. So those traits are contributing to that particular factors. So you can see here the contribution to the MGIDI. There are 3 factors and 3 genotypes. So contribution to MGIDI. So those factors or those traits are contributing. With that only it will run. If some traits are not contributing to the factor analysis, are not contributing to MGIDA. So we need to exclude them. So that's why we excluded it.
Sir, how will you get to know from this table that which factor is not contributing? Which trade is not contributing?
We have just seen, we have run with all 8 trades, then we have deleted something, then it will run. So we came into conclusion.
Sir, we have to go for hit and trial method then to understand which
What
trade is not contributing.
hit? What
Sir,
hit?
hit and trial method we have to go through because I'm asking, sir, we have to go through hit and trial method as we don't know which trade is contributing or not contributing.
Yeah.
Okay, sir.
We'll go through that also. Then secondly, this FAI blub. So just copy this, don't paste enter. We need to edit it. So here, file name is trades. So rest is same. So instead of this CGYHM, simply type everything and then press enter. So here also same thing we need to follow.
So in place of data, we have to write rate also.
It is not coming. Anything. It is coming in your system.
No, sir.
No, sir.
No, sir.
Okay, let me check it. Some error is there. Let me
Sir,
check.
the same error was there when we run the today's assignment file.
Because this data set is different, so it differs from structure to structure, file to just you can try with your old file. Some one to two other files are there with you, so you can try with those files.
So can you highlight the differences in the input file that we have run for blob and now today we are running this?
Highlighted means it is statistical difference. When it will go for vector analysis, so if there is any difference, so it is completely biometrical difference. It
Sir,
is
in
not
the
like
paper,
43, 45. So after analysis, some vectors will be there, some difference in data structure. Or if your data is not arranged significantly as per your experimental design. So
sir, how we will
that thing
determine all
also
this?
by simply calculating RBD, you will come to know whether your data is significantly arranged or not. Or whether your data is having less variability. In that case, also the stability will affect.
Okay, sir.
So if you will copy paste directly the commands I provided, so it will run as it is a default. It will take default data. This GY, HM, data GE, whatever I provided, so it will, that output will come as it will contain the default data. So see, so for this, we need to check the normality. That is also one test, normality test before going for stability analysis.
The normalization you mean?
Yeah,
Well, will you perform again this one, this FIA, FAI?
simply copy paste and enter.
Sorry, Prof. For me, I ran PH and SYKG, and I did not get an error.
Sir, what are we taking out, sir? What we have to copy paste? Which script we have to copy paste, sir?
Sir, can you repeat again this command?
As we are going for FAI blur, so you need to copy paste FAI blur. So what I told, if you open the FAI blur file, if you use as it is code, it will use whatever the default data file available in Maven package.
Sir, what is
That
the
is
meaning
the
of
name.
this line?
Which one?
It will use the default file in the
Default
method.
means each and every package, means you people ask na how these all codes are there, means no problem, someone developed, then on what basis, so they uploaded that data file. On this data we have made this code, so likewise it is available in that GitHub, that what I told you in on day one na.
Yes, sir.
So that type it is available. Just you need to search it as that database is big.
And if we want to modify that as per our file, then
So you can edit.
okay. Edit the
So
codes.
as per our file also, we can get it. Just see if we'll, as per our file, simply then we need to edit it. Like here we can add our data file name. Here you can add as it is not taking, so you can add like some characters. Then at last, so this is as per your file with respect to yield and plant height.
So
Understood?
And sir, why at the last it is showing selected genotypes G14, G1, G15?
So same three here, if you can see in the graph, three genotypes, they selected for yield and plant height.
Okay, sir.
Hello, sir.
Yeah.
Sir, can you please repeat what you told for FAI bluff? I didn't understand how this table appeared for you, because for me it is showing error.
Simply what I did, so whatever I am highlighting, this is our first command, okay?
Yes, sir.
So here I wrote our file name, that is traits.
Yes.
Then at last, first we tried with all the traits, so it is not coming as maybe difference in data structure. So for understanding, we will take when we will come for interpretation, we will analyze with normalization of data. So for understanding what I did, just I added 2 characters from our data.
Okay, sir. Up to
And
this
then
much it is appearing for me also, but that FAI command is not working for me.
Copy paste enter.
I did, sir.
There is nothing to edit.
Sorry, sir, come again.
Copy paste, there is nothing to edit.
Okay, sir. Okay, I'll try again. Sir,
Excuse me, sir.
So like we
Sir, I send you image. So
Yeah, Soundarya madam.
Sir, only 2 characters can do at a time.
Sir, it's working with only 2 traits. If I
No,
put
no, no,
3
no, no.
traits,
It is not. It will work for all. So there is a data structure vector problem. As it will work on different factor analysis. So this structure of data, so because of less variability, because of non-significance of data for particular variability, so there are different factors. Because of that, this factor analysis, maybe it is not possible. Pawan, please mute your mic.
Okay, sir.
Yeah, so just for understanding purpose, I shown you. When we'll come back for interpretation at that time, first we'll do normalization. After that, we'll move towards this one by one analysis and interpretation.
Okay, sir.
Excuse me, sir.
Yeah.
Sir, what is the meaning of normalization?
Your voice is breaking.
Sir, what is the meaning of normalization?
Whatever the possible errors I told, to check that errors and to rectify that, we have to do it.
Okay, sir.
Excuse me, sir.
Yeah.
Sir, I have sent you just a screenshot, the which you told. First, I have PH DTF means in my file there was 5 traits, and in place of everything I write all the 5 traits and run the program. Then the command came that variables with non-significant genotype effect is DTF and DTM. Then I removed the DTF and DTM and got the result.
Instead of doing this, if we will go for normalization in very first step, that also it is easy. Same thing, what you did, same thing we need to run earlier, step 1 directly.
Okay, sir.
So this is our third, that is MTSI. So just while saving, exporting, you need to change the dimensions, it will be visible clearly.
Sir, I have sent you some images. Can you see, sir?
Voice.
Sir, I have sent you some images, sir. Can you see, sir?
Yeah.
On WhatsApp.
Bluff graphs, na?
Yes, sir. I am getting error in get model data, sir. Sir, this server error is also, this is second time this is showing, sir.
Let me see. So these are the different plots. These plots are called as spider plots.
Excuse me, sir.
Sir,
Can you once again explain the difference between this non-selected and selected?
Difference I will tell now. I have not yet.
Sir, can you please show once again the FAI model, how to run it? The last command.
Okay. So see, FAI, okay. So this is our code. So here we need to change our file name. Here we can add some traits. Over. So here 3, the 3 it is not taking. What happened? Let's see. If that is internal error, if our data structure is correct, if because R is open source software, so completely that everyone will work on that, everyone will try to add the packages, try to update it. If any server error will be there, so you can try it, it will run. Otherwise, will be problem in data structure. So this is all together, this multi-trait indexing.
Hello, sir.
Yeah.
Sir, I tried for MTSI index. It is giving me the error of object MTSI model not found.
MTSI. Okay. So this is the code.
Yes, sir. First command is successfully run. I run for 2 parameters, but the MTSI
Okay.
index is not running. It's showing error.
Tell me your 2 parameters
Okay, sir.
so that I can type here.
Sir, it is pH and SY kg.
Done.
Yes, sir.
Then after this, just you need to type plot. Then MTSI index.
Okay, sir. Sir, so we do not have
model.
we do
Because
not have,
here,
sir, this MTSI index, the one you are showing right now, I'm not getting result for this. It's showing MTSI model not found.
which one? This principal
This-
components?
Yes, sir, correct. Principal component analysis.
So this first is correct only?
Yes, sir. This is correct. All variables up to this it is correct. When I type for MTSI index, it is showing error.
So clear the console and run it again. Copy paste it carefully.
Okay, sir.
Because
I will
here it is coming.
Okay, sir. I will try.
Sir, in FAI till now we have taken only 2 characters. Can we increase those number of characters?
Yeah, that's what I'm saying. Maybe if it is their software's problem, so they will rectify. So you can try that. Actually, that all these spider plots will come for all the characters. Like day before yesterday only I told you.
Yes, sir.
Day before yesterday we deal with all the traits. So as far as I am thinking, it may be the server with any small issue with this software. So they will rectify it, no problem. After that, just instead of writing the trait name, here you can write everything. So it will come like we did day before yesterday.
Okay, sir.
Yeah, and now we'll see the difference. So First is MGIDI. Then next is MTSI. Third one is which one? Multi-trait mean performance and stability index. And then what is this FAI? Factor analysis and idiotype based bluff index. FAI means factor analysis and idiotype. That is called as FAI. So, as I told you, this MGIDI, it will deal only as per the performance of genotypes. Okay. Then second is MTSI, multi-trait stability index. So that MTSI will only deal with stability. This FAI, it deals with factor analysis along with idiotype. And fourth one, that is the name itself indicate mean performance of all the traits and stability index. So all these four types of indices are there for selection of different data. Selection of different genotypes.
Can you repeat the last one?
You got the difference? I will come again. Wait. First is MTSI. So that MTSI is nothing but multi-trait stability index. So this multi-trait stability index, it will work on stability only for all the characters across the environment. That's why the name is multi-trait stability index. And day before yesterday we saw MGIDI. So what is the meaning of MGIDI? Full form?
Multi-trait iota genotype index, distance index.
Yeah. So that multi-trait genotype, idiotype distance index that deals with performance of genotype only, not stability. It will select the genotypes based on performance. So first MTSI, only stability. Second is MGIDI, mean performance. Then third one, FAI bluff. So as I told you, FAI is factor analysis idiotype. So idiotype means
Ideal plant model.
Yeah. So first it will estimate the bluffs by using mixed model. Then like factor analysis. So what is meant by factor analysis? We saw day before yesterday what is meant by factors. Anyone? So factor analysis is nothing but grouping of correlated traits into a factor. That means into one group, and that group is called as one factor. So right, first this FAI bluff, first step is bluff estimation. Second, it will combine the correlated traits into one group. and thus it will define the idiotype. That is best direction for each and individual trait. Suppose date to flowering and grain yield. If days to 50% flowering will decrease, grain yield will increase. So that's why if you will see the table, this output file, here you can see this as this both the traits are in one factor, you can see this increase. Now day before yesterday, if you have saved that output, you can see their increase and decrease. So that increase and decrease is based on that correlation. And then as per these 2-3 factors, so then it will give the genotypes ranking, and after that the selection. So this is altogether FAI block. And that last is the name itself, multi-trait mean performance and stability. Mean performance of all the traits along with stability. This multi-trait mean performance and stability index. So this is in short the difference for all these 4 methods.
Sir, I have a question.
Yeah.
Sir, then among these 4, which one is most suitable for selecting genotypes, or we have to do all?
So if you will go through the papers, many participants shared me some 2-3 PDFs. You will find all these 4 models. I will share one paper. See the WhatsApp.
Okay, sir.
Okay. Everyone, not just you, just everyone see that paper.
Sir, but
Anyone tell?
we cannot,
Yeah.
sir, but we cannot rank them according to their precision or efficiency of this model, like these 4 models.
So after running all these 4 models, you can conclude like this model is beneficial in my research. Are these out of 4, whether 2 models or only 1 model, or and other 3 models are lacking, in what sense, that also you can conclude. So that in that aspect only, this paper, delineation of selection efficiency. So here they tested the selection efficiency of this multi-trait based model in their data of per millet. So if you will scroll down, you will see that graphs. And on page number 12, you will see this, all this 2-3. Spider plots will be there.
Sir, in this
So,
paper, as per abstract, some genotypes are common in 3 to 4 models.
Yeah.
And,
Yeah.
And 3 genotypes are common in for all the models.
Yeah. So according to the efficiency of model, if you will come at the last, so see, this, if you come at the last, this G57, they are saying it is reflected by MTSI, MGIDI, and FA like what you told just now, it is already mentioned in conclusion. Then this model were consistently selected by all the models. So the main objective is whatever genotypes you are evaluating. So for that selection process, there are different model methods. So there is a less possibility of rejection of good genotype. So that is only the main objective of this, all these methods. So
Sir,
this
here,
is all the
which genotypes are selected in 2 to 3 models?
That only they are concluding. Means if any 2 genotypes are there across all the 4 models, then you can conclude like I use these 4 different methods, and from those 4 different methods I got these 2 common genotypes which are stable and high performing across whatever the number of environments, either 3, 4, 5, 8, 10. So ultimately that is the conclusion. And along with this, you see, I deleted it, I think. I will show you once. Wait. So this diagram, is it visible?
Yes, sir.
Yes, sir.
Okay. So here,
Yes, sir.
this diagram is there. This diagram is like all the genotypes rank according to the performance for the trait plant height. And now, can anyone tell what is this above and below? Above what?
Sir, your complete window is visible, but not a single graph.
Graph is not visible. 1 minute.
Your screen is visible, sir. Please select one graph.
1 minute, 1 minute, 1 minute. Now?
Yes, sir. Yes, sir. Now it is
Okay. So, this graph, it is already these 22 genotypes rank according to the performance with respect to the trait plant height. So can anyone tell me what is this above and below?
Above and below average value.
So this ranking of genotypes based on average value of that particular trait. And these are the plant at x-axis. You can see 55, 60, 65, 70, 75 and above. So right from MAUTS 70 to JH335, that performance curve is there. Then secondly, the same graph the same graph with WAAS model. So model change, ranking change. Then here also you can see PC, all 7 PCs with eigenvalue and accumulated variance. Yeah, Soundarya madam.
Sir, when we run different model, the ranking is changed. So is the different model is based on different assumption, or how, when we have to analyze something, then we do run like 2 or 3 models, and then we say
No. Just for the sake I told you, because see, now we ran BLUP as well as WAAS BLUP also. 2 models we ran, right? So
Yes.
generally in literatures or when we write in our thesis, we will go with BLUP only.
Okay.
One more. In AMI also, you will not see that WAAS AMI plot in many literatures. Majority you will see AMI 1 and AMI 2.
Okay, sir.
Because it may be this AMI stability that package is there, that is recently introduced. This WAAS also and this AMI stability that is recently introduced. So that's why it may be, that is the reason it is not there in many literatures.
Okay.
And as maybe you all are aware or not, earlier this BLUP also it is a new for this crop improvement. Generally, in many institutes or many research institute, we used to do only Eberhardt and Russell for stability. Basically, but now all these 4, 5, 6 different models are there, different graphical representations.
Okay. Yes.
So this correlations among different stability parameters like heat maps, like histograms.
And
So
if you have
likewise,
some time, could you please explain how to read the heat maps?
One minute. So it is visible?
Yes, sir.
Just a minute, some network issue is there. So yeah, this is visible.
Yes, sir.
Yeah, so on x-axis you can see first is mean. So mean of all those genotypes, right? Then on y-axis, different genotypes are there, like from
Yes, sir.
JS335, MAUS 71. Then now we'll come to colors. So some are bright green, some are dark green, and some are dark black. So
Yes,
some
sir.
are bright and some are dark. So bright green means rank number is low, genotype is better. So whatever the dark color are there, dark color are worse genotypes. As per, because we are selecting the genotypes according to these different stability parameters.
Okay, sir.
So different stability parameters. So higher the value, genotype is worst. Lower the value, genotype is better across the environment.
So it's color wise, like is the color
Color
is
wise, bright colored, wherever it is bright color, so that genotypes are better.
yeah,
Wherever
like
it is
light.
dark, so likewise in, I will give one example. Likewise in Eberhardt and Russell, if BI value is equal to 1 and and deviation is non-significant, then we'll consider that genotype is stable. Am I
Yes,
correct?
yes, sir.
So likewise, same here, bright colored genotypes are considered as stable, and dark green or dark black color, they are considered as unstable or worse genotypes based on the stability parameters.
Okay, sir.
So that is the case. Now, in short, I will tell you, because these are all the short forms. I forgot to tell the full forms of those.
Okay, sir. I will read
So
it.
just everyone, please, if you can note down, that will be easy for you.
Hello, sir.
Yeah.
In the table, we have given the numbers of genotype. How it is showing all these names of the genotypes?
In which table?
Input table, sir.
Then you can change that numbers into name of genotype, it will come. So actually these are some old figure, different figure, but if you will change that numbers into name, so like this numbers also, it will come with same script. No need to
Okay,
change
okay.
anything.
Okay.
Yeah.
I sent you a message on your chat, this on your WhatsApp. You've not responded.
1 minute, just give me 1 minute.
Okay.
I have seen that, just give me 1 minute. So now here, you let me complete this diagram. After that, I will reply you, no problem. So here first is AMGE. So AMGE is average mean genotypic effect. AMGE is average mean genotypic effect. Then next ASTAB. I will share this table with you. No problem. It will be easy. ASTB is AMI-based stability parameter. Then next ASI is AMI stability index. Like we did. Then next ASV is AMI stability value. Then that one is AVAMGE. That is sum across environments of absolute value of GEI. I will share this table. That will be better. 1 minute. You can read it. Word is fine or PDF?
The PDF.
PDF. Okay.
PDF, sir.
So just you can check the group. I am sharing it. And single table is there. So just open that. You will get all these short forms. Whatever we did with AMI stability, and now I will. I think that blobs also it is mentioned there. Yeah, AMI based stability statistics and blob based stability statistics. So likewise, you need to read the heat map.
Excuse me, sir.
Yeah.
Sir, you are telling that low rank is better genotypes, right, sir? In heat map?
Hello.
Yes, sir.
Yeah. So I am saying, I told low rank it will be stable, and
Low
high
rank will be
rank
stable.
unstable. So that ranking is not based on mean performance. It is based on the ranking based on whatever the stability statistics are there. On the basis of stability statistics, that in that heat map, the genotypes are ranked.
Okay. Sir, then to as per that rule, then dark one will be the better one or bright one will be the better one, sir?
Bright one.
Bright one will be the better one.
Yeah.
Oh. Okay, sir. Thank you, sir.
Hello, sir.
Yeah.
Can you tell some situations or condition when these models like stability model and the performance model will fail? Like earlier you said that we have to do we should know that our genotypes are variable enough.
Yeah,
So
means generally we will do that our analysis of variance and normality for each and individual data. No? Then after that we'll come to know how variable our data is. If it is not, to be very frank, if it is not significant, then we will do some more or less amount manipulation. Then if we will get significant for genotype, then we will proceed. So in
in
that
the
only, in that case only, we will come to know.
okay, but sir, we should know for what we are like doing the RBD analysis. So what are those things I'm asking basically, factors which
So
will for which
simply
we will evaluate.
means you are asking what are the situations in, it means in those situations our data can be rejected.
Yes, sir.
So no need to go further. In very first step, it will get rejected if you are if in your analysis of variance, if you will get significant replication, at that point only your data will be rejected. No one will check. No one will check what you did.
Okay.
Though you have some 100 pages of analysis, but if your replication is significant, then no one will go through that 100. They will close the book and they will say chapter is over.
And more than this replication, other than this replication.
More than this, your standard error critical difference. If your CV is more than 20, 22, like 25, 30, for field experiment, if you in for lab experiment, if your CV is 15, 17, so generally this ANOVA and in mean performance, and again next is if your your trait heritability is 20%, 30%, especially yield related traits, if you have your heritability is 20%, 30%, then that is also the case.
Okay, sir.
Yeah.
Thank you, sir.
So with related to this multi-trait, yeah, tell me.
Sir, can we start the interpretation of all the tables and graphs of
Yeah, tomorrow our first target is to finish interpretation of AMI and GG biplot. Two models will finish tomorrow. On Friday we will finish BLUP, and after BLUP on Friday itself we will revise all three models interpretation. This weekend class sessions will be there. So no holidays on this weekend.
So the assignment you have given,
Yeah.
in that for the stability we have to run all these three BLUP, GG and AMI.
Don't go for BLUP.
Okay.
Go for AMI and GG only. For BLUP, I will send you the well-structured data. That means significance data. Because up to GG, no problem. For BLUP, I will mail again. Some already shared me all the analysis. Many members, not some, many shared me. So whatever possible, you can try it. If any, yeah.
Sir, I have requested you to share codes for the alpha-latic mixed linear model.
Come again, come again, come again.
Sir, I requested you to share the codes for the alpha-latic mixed linear model, sir.
Yeah, I forgot. Now
Can
I
you-
will share after dinner. I will share. Literally, I forgot from this daily routine. I forgot it.
Okay, sir, no problem, sir. Thank you, sir.
After dinner, I will share. Sure. Just text me.
Yes,
Because
sir.
many numbers are there, so it is difficult me to identify.
Sir, I will text you, sir.
Yeah. Please.
Sir, you're not sending the video recordings again.
Videos you have you checked the website?
Yeah, but I think you've not sent the file.
I will talk with him. No problem.
Okay.
Now I will talk with him.
Okay.
I will make that arrangement.
Okay. Even though I still have not gotten what you sent, you said I should change to 2, which I did, but still not working.
Wait. I will share that all 3-4 modified script on your personal WhatsApp. Wait for some time.
Okay. Thank you.
And everyone do one thing tomorrow. Try for total characters. Maybe it is some software issue, server issue, because day before yesterday we worked for total characters for MGDI. So just tomorrow you can try it. If anyone will get success, just let me know.
Sir, I have one doubt.
Yeah.
Sir, in that NGIDI index, you have taken two traits and said that these characters are not contributing to the. You have exclude those two characters. So,
No.
how to know?
There is some error is there. Otherwise, if you will go for total characters, no, it will come. Because day before yesterday, I think you were there, no? We did MGDA. I don't know
You have
whether you
taken
were there
all
or not.
those 7 traits.
Yeah, that's what I'm saying. We already did for all 7 trades. Today, up to afternoon, it was clear, but I don't know what happened. I will also search it. You can also look after that.
My question is how to know that those characters are contributing to the factor analysis or not?
So, see, that's what before going for stability, we need to go for normalization test. From that normalization, whatever the NA values are or whatever the outliers, so that we can remove it. So as I told you, from tomorrow, we will start the AMI interpretation. So that before that, we will go for normalization. One by one command we will run, and simultaneously, I will interpret the output. So this normalization concept will be clear. No problem.
Okay, sir.
Sir, I have just run the FAI for everything, like all the characters. So it is coming.
So sometimes that maybe server error or something. Okay, so tomorrow we will start with that interpretation and other things.
Sir, can you please once tell us how to convert the text data into Excel data? How to copy it in old and in new format?
I forgot that to share. Okay, I will share that manual. Yeah. Ajeta.
Sir, there's this doubt I have, but it's not related to what we are doing today.
Yeah. Ask us.
Sir, I have this data of oil, different components of oil, because I'm working on aromatic crops right now.
Okay.
So the different components, it is 2 years data, and the components are not normally distributed. So whatever papers I could find, they are either saying that I should transform that data, or they are using a different ANOVA.
Okay.
So I'm not able to do those.
So just do one thing, whatever I told now, that normalization.
Okay.
So I will share by morning, I will share that small one 3-line script is there. So just try that 3-line script with your data.
Okay, sir.
Yeah, sir.
Sir, can we continue with this multi-trade performance stability index? That one is left, I guess. The last model.
No, this one, what I just now I performed. It is coming here, some error I am trying, because up to afternoon it was taking total characters.
Sir, can
Okay,
you
okay,
explain the code you will share tomorrow? The 3 lines code for the normalization, what that
Yeah,
will
only.
actually do with the data, how it will normalize, the process behind it.
So whatever the outliers. So outliers means some genotypes will perform beyond the range of the data. So anyone knows what is meant by transgressive segregants?
So the betterment of progeny from F2 and onward generation.
Yeah, but is there any specific characters which we can take the base for identification of that?
Those progenies lie between the intermediate value between those extreme parents.
Not
Intermediate or beyond the parental
Beyond.
performance?
Beyond their performance of the parents, sir.
Yeah, so here, so my objective to tell this example is, now we have 22 genotypes across 8 environments. So whatever the data frame is there, if some genotypes are performing beyond that data limit, so that normalization test will exclude that genotypes.
Sir, is there if there is any missing data, so is there any
That
possibility
also they
of
will remove. By normalization, that also they will exclude.
Yes.
Sir, in that case, if we are having three replications and 2 are like outliers and 1 is okay, like that is
that
lying in between the range, then
that complete genotype it will exclude.
okay, sir.
Yeah, hostelers can disconnect. Yeah, Ragini.
Sir, I sent you a query on Sunday regarding sir, how can we uh, regarding genetic variability and heritability, how can we rank the genotype the values coming as low,
Can
medium,
you
and
please
high?
reshare? Can you please reshare that to me again?
Yes, sir. Okay.
Yeah, please. Any hostelers are there? They can go. Their dinner is waiting. So our analysis part for stability is over. Now, the most important part we will start from tomorrow, that is interpretation. So some recent papers I will share where this all 4-5 models along with these spider plots they use. So 2 to 3, not more. 2 to 3 papers only I will share, so that after session also you can go through that. and it will be in your mind. You will not forget. Yeah, alpha lattice I will share after dinner for sure today.
Okay, sir.
Yeah,
I sent
Agini,
you the file again.
I will, yeah, I PCV 30. Where is heritability? Yeah, categorization is correct.
Sir, but I have found that in different papers they have taken different values. In some
No,
paper
but
they are saying
whatever you
that
shared,
above
na,
60 we take them as.
whatever
Yes, sir.
you shared, more than 80% is high. So that is, as far as I am thinking, it is correct only. 50 to 80, rather 50 to 80, I will say 60 to 80. You can make it.
Okay,
0
sir.
to 30 low, 30 to 60 it is average, 60 to 80 it is medium, and 80 above is high. So those who are working on field, they can understand this very easily that above 80% only it is correct. Your character, your this
Okay, sir. Then, sir,
categorization is
which
correct.
category we can?
For improvement, you are
Sir,
saying?
I'm saying that somewhere. Sir, I'm saying that I have made two columns. In some papers, less than 50% is taken as low, whereas in some, less than 30% is taken as low.
No, that threshold level, as we have seen during our augmented diagram also, that threshold level is 30, 60, and 80. But that you can change,
Okay, sir.
you can change that threshold level in your planning. You can change in your planning. That is not like it is given 30, so you have to take only 30. You can change. Generally, for trait selection, we will take more than 80%.
Yes, sir.
The trait with more than 80% heritability.
Okay, sir. Okay, sir. And sir, similar cases there for genetic advance and also for PCV and GCV.
Yeah, that you can take highest values. What I told, threshold you can adjust according to your objective. So you can't say like 50% I will select the trait 50% and I will start working on that particular trait. So that is very difficult, and it is of no use.
Okay, sir. Sir,
Yeah.
then
So
for
if
genetic
you
advance
will
and
say,
genetic envy.
yeah, complete your question. Complete your question.
So then what are the threshold values for genetic advance and genetic gain and also for GCV and PCV?
So as like threshold values, as like thumb rule, threshold values are not there. But generally, what
Okay, sir.
for conclusion, what we will say now, high heritability.
Yes, sir.
First criteria, high heritability with high genetic advance and high genetic gain. So that combination we will see.
Okay, sir.
Yeah.
Okay, sir. Thank you, sir.
Okay. So we will start that interpretation part tomorrow. Tomorrow onwards, tomorrow and day after tomorrow, we'll do fully interpretation. And still, if you have any queries, just reach out to me on via my WhatsApp. Okay.
So similarly, there is also no thumb rule for genetic coefficient of variability and phenotypic coefficient
No,
of
no, no,
variability.
no. Generally, see, I will tell you that
Yes,
in
sir.
1 minute. 1 minute, 1 minute, I will tell you. So just the thing, GCV and PCV, only criteria is there. PCV will be on higher side because of environmental effect. It will be on higher side. GCV will on lower side. Like genotypic variance and genotypic coefficient of variance will be less than phenotypic. That is the criteria.
Yeah. Okay, sir.
Clear?
Yes, sir. And sir, is there any such criteria in case of genotypic correlations and phenotypic correlations?
No, it is like just we'll see the relationship for between two variables uh, by genetic effect and phenotypic effect. Like days
Yes,
to
sir.
flowering with
Sir,
gray yield. So generally we'll say like it should be negative significant.
mhm. Sir, is there any criteria also in that genotypic coefficient should be higher than phenotypic coefficients, or is it not there?
No, that phenotypic will come on higher side
Sir, in
because
correlations also.
that environment will play the part, na?
Okay, sir. Sir, it will be also in correlations,
Wherever,
phenotypic correlation values will be higher.
wherever environment will play the part, that phenotypic effect will increase.
Okay, sir. Sir, I'm asking in correlations also it will be same for that phenotypic correlation values will be higher.
Your voice. You are asking any threshold?
Sir, I will text you.
Text me, no problem. Okay. Okay. Thank you. So we'll meet tomorrow 6:15. Okay. So thank you everyone.
Thank you, sir.
Thank you, sir. Good. Thank you, sir.
Okay.